Welcome to this PyTorch training session. Today, we'll explore how PyTorch empowers developers to build, train, and deploy deep learning models with flexibility and ease. PyTorch is one of the most widely used deep learning frameworks. It's open source, built by Meta, and known for its dynamic computation graph, which makes experimentation and debugging much easier compared to static frameworks. Tensors are the building blocks of PyTorch. They're similar to NumPy arrays, but optimized for GPU acceleration. With tensors, you can perform mathematical operations efficiently, which is essential for training neural networks. Autograd is PyTorch's automatic differentiation engine. It tracks operations performed on tensors and computes gradients automatically. This feature powers backpropagation, the core of training deep learning models. PyTorch provides nn.module to build neural networks. You can stack layers like linear, convolutional, or recurrent, and define how data flows through them in the forward pass. This modular design makes it easy to experiment with architectures. The training loop is the heartbeat of any model. It starts with a forward pass, computes the loss, performs a backward pass to calculate gradients, and updates weights using an optimizer. This process repeats across epochs until the model converges. PyTorch makes data handling simple with dataset and data loader. They allow efficient batching, shuffling, and loading of data. You can use built-in datasets like MNIST or create your own custom dataset classes. One of PyTorch's strengths is GPU acceleration. By moving tensors and models to CUDA devices, you can train models much faster. Always check if a GPU is available and leverage it for heavy computations. Beyond the basics, PyTorch supports advanced topics like transfer learning, where you fine-tune pre-trained models, sequence modeling with RNNs and transformers, and distributed training across multiple GPUs for large-scale projects. To succeed in production, follow best practices. Save checkpoints regularly. Log experiments with TensorBoard. Monitor GPU memory, and write modular code. These habits ensure reliability and scalability in real-world AI systems. In summary, PyTorch combines flexibility and power. By mastering tensors, autograd, and training loops, you'll have the foundation to scale into advanced architectures like transformers and multi-agent systems. Thank you for joining this session.